Alrighty, in today's video, we're going to be talking about 5.4 inverses of functions. This will be our last topic before our next test, which you will have open after your fall break. So you'll have a week off to make sure you get the Chapter 5 homeworks done, time to study. I believe I still open the practice test this Friday. If not, it was the next Friday, but it's going to open up eventually. And then you'll have your test that'll open up on the 27th. Remember to get your work scanned and turned in. There will be no extra time on this one. If you don't get the requirements done, there will be no leniency. All right. So remember, get it. You got 7 days to take the test. And then I think on this test, you'll be given 3 hours. I don't think you'll need 3 hours, but you'll have 3 hours. So make sure you give yourself that much time. And then get it scanned and turned into Blackboard to get your full credit for that as well. And again, if you have questions, not the Sunday when it's due, but before then, I don't mind addressing those as well. Other than that, just be over, I believe, chapters 3, 4, and 5 is what this test will be over. And this will be your second out of three tests. All right, so again, in 5.4, talking about inverse of functions. Basically, if you are given a coordinate AB, its inverse would be BA. Oop, that's an X. So since you have your domain is your X's and your range is your Y's, the inverse would flip that. So now your domain is the Y of the original function. And your range is the X of the original function. So that's how inverses work there. Basically just flip the X and the Y. That's the main gist. And a couple of things to kind of talk about is you can actually do the horizontal line test to determine if the original function, f of x, has an inverse. So if it passes the horizontal line test, then f of x in itself will also have a inverse. We know the vertical line test just tells us if it's a function or not. The horizontal line test will basically tell us if our inverse function would have been a function or not. The next little big tidbit is one-to-one. So we know that every x value has to have a unique y value, but to be one-to-one, every y value will also have a unique x value. So every x and y values are unique to each other. I learned the other day that unique is not one of y'all's words that y'all just know. A unique meaning that there's only one answer, right? So unique is just meaning one. So for every y value, there's only one x value, and for every x, there's only one y value. So that would make something one-to-one, which will also let you know it has an inverse function, that either the function and its inverse are both functions in itself. The next thing is you need to be able to find the inverse. So it's 3 steps. We're going to change f of x to a y, switch x and y, and solve for y. And then the third step, change y to f of -1 of x. This right here indicates inverse, not the fact that I'm going to make it a rational function. All right. Also, we can note on a side note, if you were to take the composite of the function and its inverse, and take the inverse of its original function, the composite of that one, and you get x for both, then you know that they are inverses of each other. Right. So if I'm trying to determine if something's an inverse, I can just plug it into each other. If I get x, then I know it's an inverse rather than having to go solve for what the inverse is. So sometimes that makes the process a little bit easier and faster. So that's pretty much all the notes that are in 5.4. So let's get into some examples. So we'll be on page 361, and we're going to look at number 1. So you are given r equal to -4, 2, 3, 2, 0, -1, and 3 and -2. And it says graph the inverse of each of the following relations and state its domain and range. So the easiest thing to do here to find the inverse is just flip the x and the y. So the new coordinates now would be 2, -4, 2, 3, -1, 0, and -2, 3. So its domain will be basically the y values of the original function. So I'm going to put that in least to greatest, and I don't repeat. So that would be -2, -1, and 2 would be the domain. And the range of the inverse would be, it's like -4, 0, and 3. All right. And then to graph it, this becomes 1, 2, 1, 2, 3, 4, 2, 1, 2, 3, -1, 0, and then -2, 3. All right. And I believe that's all it wanted you to do. It says graph the inverse of each of the functions. Perfect. And then state the domain and range, which we did that as well. Yeah, perfect. All right. Just wanted to make sure I got all the values there. All right. Other than that, that's pretty much all you're going to see on that type. So let's jump into the next type of problems that you will see. Let's look at number 18. In this set, it says to determine if the following functions have inverse functions. If not, suggest a domain to restrict the function so that it would have an inverse function. So you're given g of x equal to x minus 2 squared minus 1. And you're simply, sorry, that's a cube. And on this one, you simply just have to determine if it has a if it has an inverse function, and if it doesn't, restrict it. So the easiest thing to do on these is to actually graph these. And again, you can use your graphing calculator, but just in case you have a professor that ever tells you can't use a calculator, remember that from the previous sections, this is a cubic function that has just been shifted right and down. So I went right 2, down 1. But this right here would be what your graph would look like. So to determine if it has an inverse, you just have to ask yourself, does it pass the horizontal line test? If I draw any of these lines, does it cross your function more than once? And I can't think of any of them. So yes, this has an inverse. All right. And that's all you have to do on these types. So let's look at number 25. So you're given f of x equals x squared minus 4x. Again, this is a quadratic. And I could, again, graph this. I can factor out, make it a little bit easier for me. I know there's a coordinate there. And 1, 2, 3, 4. I know there's a coordinate there. I'm going to know it's going to open up. So let's see. So negative b, that's going to be 4 divided by 2. So that's 2. So at 2, that's going to be my middle. That's going to be 4 minus 8. That's -4. 1, 2, 3, 4. All right, so give or take, this is what your graph will look like. But again, if I try to do a horizontal line test on the very first draw, I can see it will cross more than once. So in this case, an inverse doesn't exist unless I give it a restriction. The best way for a quadratic to have a restriction, figure out what the x value is. So in this case, that's 2. And the way I did this, by the way, from our previous sections is the negative b divided by 2a. So that had been negative 4 divided by 2 times 1. So that's 4 divided by 2, which is 2. So that right there, my axis of symmetry. If I restrict my domain to basically be from 2 to infinity, including the 2, I can now have my restricted domain. Or you could technically do negative infinity to 2 as well. But either way, if I just took half of the quadratic, then I could see if they cross or not. Give me 1 second. So again, if I cut that quadratic in half, I can see that it would pass the horizontal line test. So that's what it means by trying to come up with a restricted domain. All right. And again, it could be either one of these. It does have to be either or. I mean, both. It's just either or of them. All right. So that's one type of questions you'll see. And then you have a big chunk in this next section. So let's look at these. So look at number 29. It says find a formula for the inverse of each of the following functions. If necessary, first restrict the domain of the function. So here we go. So I'm going to take the function. I know that this is a cubic function. So again, you can graph it first. This means I'm going to go down 2. So my cubic functions look like this right here. So I know that that will pass a horizontal line test. So there's no domain restriction. So now I can go straight into solving it. So step 1 was to change f of x into a y equals. Step 2 is to switch the x and the y. So now it's x equals y to the 1/3 minus 2. And then now solve for y. So I'm going to add 2 on both sides. So I get x plus 2, y to the 1/3. To get rid of a third, we're just going to raise it to the 3rd power. So now I get y equals x plus 2 to the 3rd power. And then the third and final step is we're going to change y to f inverse of x, and then just rewrite what we just solved for. There you go. And now you just found your first inverse by hand. And that's all you have to do. So you check first, and if you have to, you put some restrictions on it. The math's not going to change even with the domain restriction. The only thing that would change is at the very end of this, you would then limit the restriction to whatever it might be. All right, so let's look at number 31. This is r of x equals x minus 1 over 3x plus 2. This is a rational function, which I know just have basically branches. So it could look like this, or it could have them both. Well, if it's both on the same side, that'd be different. That'd be a square. But they're odd. So therefore, there would be no domain restriction. If this was a square on the bottom, I would then have something on top here. But in this case, there's no restriction, so I can go straight into solving. So again, step 1, change your r of x into a y equals. And then step 2, switch your x and your y. Now this is another x right here, so it'd be 3y plus 2. So make sure you change them all. And then now I'm going to solve them. So the very first thing I need to do is multiply both sides by 3y plus 2. So I can get rid of that fraction. So this will be 3xy plus 2x equals y minus 1. My next goal is to get my x's and y's on one side. So I'm going to add 1 here, and then I'm actually going to subtract 3xy here. That will go away. This just becomes 2x plus 1. That will go away, and this becomes y minus 3xy. The purpose of doing this is now that all the y's are on one side, I can factor the y out. So this will be a 1 minus 3x. Always check yourself to make sure it can go back to its original thing, equals 2x plus 1. And then now I can just divide by that 1 minus 3x. So I got all solved for y. So my third step, which is now to change the y into f inverse of x, or I guess, sorry, in this situation, it would be r inverse of x. And in that case, it would be 2x plus 1 over 1 minus 3x. And there's your first rational inverse that you've solved. And that's pretty much it there. All right, let's see. Let's look at some others. I'll make sure you have plenty of examples. Let's look at number 34. 34 says g of x equals the cube root of 3x minus 1. Again, this is a cube root, so I know it's going to look something like this. It might be shifted, but I know that passed the horizontal line test, so I don't have to worry about any restrictions. So now I'm going to replace g of x with a y. And then I'm going to switch x and y. And now I'm going to solve for y. So now to get rid of a cube root, just like before, just now written as a radical rather than a rational exponent, as I will still raise it to the third power. So that now gives me x, almost drew a 2 there, x cubed equals 3y minus 1. And then now I'll add 1. That gives me cube root plus 1. And then I'll divide by 3. So now that I solved for y, my final step is to rewrite it as capital G inverse of x equals x cubed plus 1 over 3. If it doesn't accept this as an answer, you're more welcome to write it as 1/3 x cubed plus 1/3, but I'm pretty sure it will. But I have seen some homeworks in the past want you to separate it like this, but I'm good either way. So this is more of an appropriate answer. And I think this time I got it fixed to where it'll accept that as an answer too. All right, let's do some more. 35. We have v of x equal to x plus 5 divided by 2. So again, this is actually just a linear function. So a linear function looks something like this. So I know it's definitely not going to have any restrictions. So I can go straight into solving. So again, change v of x to a y. And then flip or switch the x and the y. And now solve. So I'm going to multiply both sides by 2. So it gives me 2x equals y plus 5. And then I'll subtract 5. So I get y equals 2x minus 5. So then the third thing is this becomes v inverse of x equals 2x minus 5 as the inverse. All right, let's see if I can find another one. Let's look at 37. 37 is h of x equal to x to the 3/5 minus 2. I actually don't know. See, this would be a cube root of x to the 5th. I feel like it would still resemble maybe something like this. Yeah, so I'm thinking that you'd have to graph and verify, but I think it looks something like that, which I think it'll still pass the horizontal line test. Because because again, for every x value, there would be a unique y value because you're raising it to the fifth power. So you have a positive and negative results. So you wouldn't have double the answers. I'm going with this is where I'm going with it. I think it looks something like that. And so it has no domain restriction. Correct me if I'm wrong, though, if y'all go through and goes, yep, that definitely fails the horizontal line test, but I'm pretty sure it'll pass. Regardless, I'm going to change h of x into a y. And then I'm going to solve for, next step, switch the x and the y. And then I'm going to solve for my y. So I'm going to add 2. So I get x plus 2 equals y to the 3/5. To get rid of a rational exponent, you just have to raise it to its reciprocal. So instead of raising it to 3/5, I'm going to raise it to the 5/3. And when I do to one side, always do to the other. So I now get x plus 2 raised to the 5/3. And that would equal my y. So then the third thing, as I would then write my inverse notation, equal to x plus 2 raised to the 5/3. All right, so let's do another one. Let's look at number 38. 38, we are given a of x equal to x cubed plus 1 raised to the 1/5. And again, on this 1/5 here, I knowing about my negative exponent of the power functions from the very first part of this unit, that would give me a odd radical, so that'd be something like this. So it's going to give me some type of function like the cubic. The fifth root would do the same thing. So it's going to get something like this, so I think I'm good to go. Again, I don't think there's any domain restriction. So when I'm working through this, I'm going to change a of x to a y. And then I'm going to switch my x and my y. And now I'm going to solve. So I'll raise both sides to the fifth power, because that will get rid of the 1/5. But of course, I have to do it to the other side. So this gives me x to the fifth. This will cancel. And so this gives me y cubed plus 1. So then I'll subtract 1. So it gives me x to the fifth minus 1 equals y cubed. And to get rid of a cube, we just take the cube root. So therefore, my third and final step, change y into the notation of my inverse, and I get the cube root of x to the fifth minus 1. And again, that being a cube root, I definitely know it's going to be a function. All right, then we get to number 39. 39 is j of x equal to 2 over 1 minus 3x. Again, knowing that this is going to make some type of rational function, it's going to pass the horizontal line test. So I can go into my steps. So this would be y equals 2 minus 1 over 3x. Switch my x and my y. So I get x equals 2 over 1 minus 3y. And then now solving for it, I'm actually going to multiply both sides by 1 minus 3y. So I can get rid of the fraction here. And so this will give me x minus 3xy after I distribute there. Gives me 2. And then I'm solving for y, so I need to get everything away from the y. So I'm going to subtract x. I get negative 3xy equals 2 minus x. And then I would divide by negative 3x. So now I can see my third and final part of the answer would be the inverse of j would be 2 minus x over negative 3x. And that's pretty much all of those types. And I think there's only one other type of question I saw. So let's look at number 51. In this one, it says this, in each of the following exercises, verify that the two are inverses of each other. So you're given f of x equal to the cube root of x plus 2 minus 1. And then you're given the inverse is x plus 1 cubed minus 2. And this is asking you to verify. So to verify this, you would simply just find f of f inverse of x, and then also find f inverse of f of x. So I'm going to take this guy right here, and I'm going to plug it in for my x. So this right here would now be the cube root of x plus 1 cubed minus 2 plus 2 minus 1. All right, so when working this, I guess I really didn't need these parentheses because there's no exponent there. So I'll get rid of those. And then I can see that the 2's would cancel. And then once the 2's cancels, I can see that the 3's would cancel. So it'll be leaving me with x plus 1 minus 1. And I can see that the y's would cancel. So I verify that that does equal x. And then you just come over here and do the same thing. This time taking this function and plugging it into the x. So this is now going to be parentheses, cube root of x plus 2 minus 1 plus 1 cubed minus 2. So I can see that those cancel. And I now have the cube root of x plus 2 cubed minus 2. So those would cancel. So I get x plus 2 minus 2. I see that those cancel, and I get x as well. So I now know that those are inverses of each other. So it was one of those type of questions in there, so I want to make sure you saw how to prove that they are inverses. Other than that, that will pretty much wrap up chapter 5 and wrap up everything that's going to be on the second test. Again, I think I have it opened up for this Friday, and you'll have the entire fall break if you choose to work on it. This homework is not technically due this Sunday. You do have until the Sunday of your fall break. If you need the time to get it done, or you can knock it out before your fall break. You don't have to worry about it at all. But the test will open up the Monday we come back from fall break, I believe on the 27th, and you'll have until the November 2nd, which is that Sunday, to again get the test done, get your work scanned and delivered into Blackboard. And there will be, again, a spot where you just simply say true or false. You did do it. You did upload it. You're good to go. And again, there will be no extensions this time. So if you're having any technologies issues, get those taken care of through your ID department. I did actually email y'all's IT department, and they said y'all had to do is simply restart your computer, and it worked. But if I get emails again on Sunday, the day it's all due, saying that something's not working, again, you should not wait until the last second to verify things are working. There will be, again, no extensions. Other than that, if you have questions over the material, again, keep on emailing me with the questions, and I will continue answering any that you have. Other than that, that is all that I have. So I will see you in the next video. Bye for now.